basically one equation out of this. You are seeing two equation, every equation is a separate ARDL model, right? No. Uh, Basically, when you are having only one variable in which you are interested and you are trying to find out the determinant of that model, then you need ARDL. But if you are working on two variables simultaneously, then you may need the vector autoregressive. Suppose your objective is only to look at the behavior of consumption. There is only one variable whose behavior is of your interest, then you may use ARDL. But suppose you are interested in a number of variables, for example, what is happening to the consumption and exports simultaneously, then you may need the VAR kind of models. Yes. Look, there are some kinds of endogeneity. Basically, when you are making the ARDL type of analysis, there might be endogeneity in this as well, but there are some types of endogeneity. Some can be handled without having VAR and some cannot be handled, but there are other ways to handle these. But the issue is, if you are interested in two variables, in looking at the behavior of more than one variable simultaneously, then you need VAR. Okay, so these are the assumptions of the model, but look, you may have the thing like this, covariance of epsilon 1t and epsilon 2t. One is coming from the first equation, second is coming from the second equation. So there is no restriction on this. This can be non-zero. Okay. It can be non-zero. Another objective of making VAR models is to see the impulse response. What is impulse response? Suppose you are providing artificial shock to one of the series. What will happen to the series in the system in future? For example, you have a VAR model in which there are consumption and income, and then government spending. What you are doing, the government is consuming 10 billion extra. It will affect the other two series as well, but how it will affect, it can be checked by impulse response function. And the impulse response is calculated from the vector autoregressive model. Basically, you can calculate the impulse response for any other thing as well, but this is most frequently used. And this is what is available in the softwares. And suppose you want to calculate impulse response in case of simple ARDL model, you have to do it manually. But if you are going to use the EVUs only to calculate the impulse response, then EVUs will do it only on VAR model. Okay, so basically as I have said you that the assumption of this model is epsilon 1t is having no serial correlation. This is not correlated to its own past. And similarly, epsilon 2t is also not serially correlated. This is not linked with its own past values. But there is possibility of correlation between this and this. Suppose this is epsilon t 1t and epsilon 1t minus 1. So covariance of these two should be 0. But suppose you have covariance of epsilon 1t and epsilon 2t, and then there is no restriction on this. This can be non-zero. And it often happens that this is non-zero. So, you need to do bound testing. Yes. You can do co-integration testing which is based on the VAR models as well. You don't need necessarily to go for the bound testing type of approach. There is another test for co-integration. You might have listened to the name Johansson co-integration. The Johansson co-integration is calculated on the basis of VAR. If you don't have co-integration, no, that's not correct. So let me discuss the co-integration before we go to impulse response function, because you people sometimes have more interest in co-integration type of things. So we have this kind of model. What happens? I can write this model as xt is equal to a1 x t minus 1 plus epsilon t. So the x is being regressed on its own leg, and with some kind of transformation you can write the same model in this format. Del xt is equal to pi 1 x t minus 1 plus say gamma 1 del x t minus 1 plus epsilon t. Basically, if you subtract the xt minus 1 on both sides, you will get this kind of transformation. Now, the logic that we have studied about ARDL co-integration is also working here. Suppose you have x and y which are I1, meaning xt is I1. Then what happens if xt is I1? Then del xt is I0. Okay, so now this del xt is I0 and del xt minus 1 is also I0, and in order to have the balance, both sides of the equation must be I0. So that means that this term is also I0. What this term is actually, this is equal to pi 1 1, pi 1 2, pi 2 1, pi 2 2, right, into x t minus 1, y t minus 1. Okay. This whole term should be equal to I0, right? This is also equal to saying that pi 1 1 x t minus 1 plus pi 1 2 y t minus 1 is I0, and similarly pi 2 1 x t minus 1 plus pi 2 2 y t minus 2 is I 0. Now again the same logic that we have studied yesterday is also working here. See, I have said if x is I1, then del x is I0 and del xt minus 1 is also I0. This must be I0 in order to have balance on both sides. So this means that this term should be I0 and this term should be I0. And it could be I0 in two formats. The first is what we want to say is, in order to have the balance, we should have pi 1 into xt minus 1. This should be I0. Right? This means there are two possibilities. Either first is pi 1 is not equal to 0, but pi 1 into xt minus 1 is I0. And the second possibility is pi 1 is equal to 0, and if this is the case, then the case will become trivial. You will have no term here. It will eliminate and you can get the balance on both sides. But suppose the situation is like this, pi is not equal to 0. This means at least one of these two rows is non-zero.